Hey, and welcome back to Wheat Beat. My name is Mike. So today we're continuing on with our series on sourdough bread with a little more emphasis today on pH and acidity. We're going to do a quick little experiment to look at how the amount of sourdough starter you use affects your outcome, and then we're going to do a bake to test some of that stuff. So join me today and let's get started. All right, so let's get started with some basic questions and answers. The most common question that I hear is, well, what is the difference between regular bread and sourdough bread anyways? Don't they all just use yeast? And the answer is yes, they both have yeast in it, but the big difference is that sourdough has bacteria. And where does that bacteria come from? Oftentimes just from the air. And when you propagate, when you grow that bacteria, that's known as a starter. So it's a little bit of yeast and a little bit of bacteria. You grow it in an environment that's rich in energy, like flour and water, and you populate that. And that is your sourdough starter. So the main difference, bacteria. So the next question you might ask is, well, what do those bacteria actually do? And the bacteria have very important function. They create acid, they create carbon dioxide gas, and they create alcohol. And we're going to talk about each one of those components in more detail as we go through the series, but today we're going to concentrate on the acids. All right, so what's the big deal with acid? Well, acid creates the flavor. You have acetic acid, which gives it a vinegary flavor, and you have a lactic acid, which is more of a yogurty flavor. But the important thing here is that the acid gives it the distinctive sourdough flavor, which comes from the bacteria. But what else does acid do? Well, it turns out that it also activates and deactivates very important enzymes that are working in the process of bread making. We're going to talk about that in a different video, but we'll save it for now. Just to understand, though, that the acid does change the properties of the gluten and the minerals and all sorts of things that are going on in the background. Okay, so now we've established that acid is important and it plays a big role in sourdough bread. Well, how do you measure it? You want to measure it in order to know how much of an effect it's having on your bread and what kind of effect it's going to have on flavor. And the easiest way to measure that is with pH, which is basically the potential of hydrogen. You use a pH meter like this and you can actually check and see what your pH is over time, and then from that you can extrapolate what effects it's having on your dough. The other way to do it is the way chemists do it. It's something called titration, and it's a much more accurate way to measure acidity. I guess the only thing to understand from here is that the pH meter, or measuring pH, is sort of an indirect way to measure acidity, and it's a good guide, but it's not a direct measurement. pH goes from 1 to 14. 14 is extremely basic, 1 is extremely acidic, and 7 is exactly neutral. Now, when I start doing these processes, I go with a very vague range, but most would agree that around pH 4.7 is a good time to divide your dough. And around 4.6 is when I would shape the dough, and then I would wait for it to be 4.1 when I actually put it in the oven. Now, of course, different people will say different ranges are more appropriate, but that's a pretty good starting point. You might be asking, well, why is this important at all, and how is it happening over time? I mean, how is the pH going down? Well, the bacteria are creating the acids, and they need time to do that. So you know, if you've ever gardened, you plant 1 or 2 seeds, you're going to get 1 or 2 plants. If you spread a ton of seeds, you're going to get a ton of plants much more quickly. And the same concept goes here. Your seeding, or the amount of starter that you use, is going to affect how quickly the process goes. And the more bacteria you put in there, or the longer you give them to work, the more they're going to create acids, and the more the pH is going to drop. Now that becomes important when you start talking about the starter, because a lot of people say, well, how much starter should I be using in my dough? I use 10% of my flour weight, or I use 20%. Well, it almost doesn't matter to some extent, because it depends on how long you want the fermentation process to go. The more you seed it, the faster the process is going to go. If you just add one bacteria in there, it's going to go very, very, very slow, because that bacteria is going to need to reproduce many, many times before it has a meaningful effect on your dough. Well, how much does the seeding affect my timing? And that timing is important, as we said. It affects how quickly fermentation goes. It affects the properties of the gluten and your dough in general. It affects the flavor. There's a lot going on there. But I'm not necessarily interested in what changes based on speed. I'm more interested to understand how the amount that I seed the bread is going to affect my timing. So I did an experiment, and here's the experiment. I basically set up a bunch of these sample pieces of dough, and I put 2% salt in there, just like I would in regular dough. And the only difference was how much I seeded it with starter. So in the first example, I did nothing. I just put flour and water and salt and put absolutely nothing in there. And then the next one has just a very small amount of starter, a little bit more starter, and so on until I got to a point where I had a lot of starter in there. And then what I did is I took the pH meter and I measured it along the entire process to come up with this graph that you see here. So what you're seeing here in the graph is how over time, over a 28-hour period where I did this, you can see how the pH is changing, how the acidity is going up relative to the amount of time. And one of the first things that you can see very clearly is that the more starter that I put in at the beginning, the faster the process went. The process actually went at the same rate. It just started sooner the more starter I had. The other super interesting thing that came out of this is in the first few hours, I actually mixed this like I would in a normal dough. I didn't just do this once and then leave it and measure it every 30 minutes. I actually mixed it for the first few hours just like you would normal bread. And one of the things you notice is that the pH is actually going up. It's actually getting less acidic. Well, how can that be? And I reached out to Tomas Tefri Chamberlain, who's the person that I worked with, who's really an expert on the topic. And he and I are talking more about what could have led to this and what other experiments we can do to find out why in the world the pH would actually go up in the first few hours while you mix it. He has some theories on on ammonia being produced and other things that cause a basic environment during mixing, but we'll get into that in a totally different video. The important thing for here is just to note that in my control, you notice that it's pretty much flat. The pH hasn't changed at all until we get to about hour 24 or so, and then it starts to drop. What happened there was that the bacteria from the air was actually starting to replicate and create an effect on the dough. So if you've ever heard of people creating their own sourdough starter, all you really need to do is just leave flour and water out in the open and just refresh it every 12 to 24 hours for about a week, and you're going to get your very own sourdough starter. But here is a proof that it can start all on its own without me seeding it with anything. But for the ones that I did seed it, you can see that as I got from 2% to 5%, 10%, 20, and 30%, the rate at which the pH dropped was the same. It just happened much sooner. So then if I draw a line at about pH 4.7, which is where I want to start dividing my dough, you can see how based on the amount of starter I put, I start dividing my dough at different times, and I can actually pinpoint when those times are. Same thing with shaping, and of course same thing with baking. So now that we have a chart like this, first of all, it's very interesting to look at it because you can almost put this on your refrigerator, and if you're trying to bake your bread at a very specific time, you can almost follow along with this and get a very good general idea of when you're going to go into the oven based on how much starter you use, and you can modify your formula to suit whatever timing you want for that bake day. But I went ahead and decided let's apply this knowledge and see if it's really true. So I took my tried and true sourdough formula, and this time the big difference was that I was measuring pH. Before I never did. I just followed the formula. It said after 3 hours or 4 hours, go ahead and divide it and then proof it for another 4 hours and then put it in the oven. But I had no idea what the pH was, which means I don't really know where it was in the process. So this time I measured the pH, and here's what we did.
Here's my levain in the morning, and we're at 4.1 at 70, almost 4 degrees Fahrenheit. Okay, here we are after 30 minutes of fermentation. Here we are at about 3 hours. And we're at about 5.12. Here we are at 4 hours. Now normally I would stop at this point and divide and shape. We're at 4.90. So based on this, I'm actually going to wait longer.
So I'm measuring it and I'm finding out that actually my pH is a little bit too high for when I start dividing the dough. I actually ended up waiting longer until the pH went down into my more desired 4.7 range, which ended up taking a whole nother hour.
Okay, so I've finished dividing and shaping, and now my pH is 4.6, which is exactly where I want it to be. So we needed to bulk ferment for an hour longer than was in my formula. So already I'm learning something new from checking the pH. So we're going to leave this proofing until we get closer to the 4.2 range, and we'll see how long that takes.
So you have to remember that your temperature has a big effect here as well. So all of these things that I did in the experiment were done at 75 degrees Fahrenheit. But if you're at 70 degrees Fahrenheit or 65 degrees Fahrenheit, this may happen at half the normal rate. You can't necessarily rely on just time. You also have to look at temperature. And when you measure pH, you're really seeing what's actually happening in your dough, which is super cool. But when I went through this, the interesting thing was that it actually went according to the time that I did in the experiments, which means that what I had here in the chart translated into a real world bake, which was super cool to see. And I found that to be very useful so that I can use it maybe for the future.
Okay, so it's been exactly 1 hour and we are at about 4.4, and that is actually right in line with our graph. So according to this, it should be about 2 more hours of proofing. It's now at 4.22 down from 4.4. So at this point, I think I'm gonna get ready to put it in the oven. I'm gonna give it another half hour or so and then we'll get it in. And I am at 4.1 now, almost 4.1. So this would be a young Levant. Pretty much perfect time, I think, to put it in the oven according to our criteria that we set. Yep, there we go, 4.1. So I'm going to go ahead and bake this off, and then we're going to see what comes out of it. Also, in terms of the proof, when I put my finger here, it looks like it's staying indented and springing back very, very slowly. So that would be another sign that the proofing is in good shape. All right, here's a final loaf, and looks pretty good. And we'll go ahead and slice this open and see what it looks like inside. All right, and here it is sliced open, and yeah, it looks pretty good. Pretty nice crumb, irregular holes here, but it's dense enough that you can make a sandwich out of this, so it's not obnoxious. And let's give it a quick taste here. Yeah, it's good. You can definitely taste the sourness. It's not very sour. So I'm starting to think maybe I could have gone a little bit longer, maybe into the 4.0 range before baking. But the interesting thing here was just being able to time the bake based on the pH, and that's something new for me, and certainly a new tool that I think helps me refine the final product.
So that doesn't mean you have to run out and go get a pH meter. It just means that it plays a big role and we're learning more about how it affects the quality of your bread. And one of the things we looked at in today's episode was the amount of starter that you use in your sourdough bread and how it affects your timing and how it will ultimately affect the long-term product. So that leads into our next episodes, with more focus on the enzymes that are affected by acidity and other properties and how gluten is affected by the acidity. So there's a lot more to talk about. This is just getting started, and I hope you continue to join me for the next episodes. Until we meet again, go out and bake something.